Okay. We have ourselves another separable differential equation with an initial condition. That's our initial condition right there. Y of 0 equals 2. Okay. Some of these problems, they don't necessarily look separable at first, so you got to play around with the algebra until you make them separable. Okay, so the first thing I would do is, you always want to get dy and dx onto opposite sides, and so get rid of that 0. Let's move the xy over there. So 1 plus x squared dy over dx is going to equal now negative xy. Okay. Now move everything with x's over to that side of the problem and everything with a y over to the other side of the problem. Okay, so that would give me 1 divided by y dy is going to equal now negative x divided by 1 plus x squared dx, like that, and then we can integrate both sides. All right, now the integral of 1 divided by y is that's not bad. I mean, it's just the natural log of y. It's a standard integral. This thing right here, negative x divided by 1 plus x squared. Okay, this is going to take one of our techniques of integration. Okay, now when I look at this problem, I see, all right, I've got an x squared on the bottom of the problem, and I've got an x on the top of the problem. Now remember, if you let u equal, let's say 1 plus x squared, du is going to equal 2x dx. So we are going to let u equal 1 plus x squared, okay? So the du equals 2x dx, okay? That doesn't really work yet because we have du divided by 2 is going to equal x dx. We do have an x dx inside the problem, okay? Okay. So the integral of 1 over y, let's just go ahead and do that so I don't have to do it over again. Or write all that. Okay, so that turns into the natural log of y. That minus sign right there, I'm going to go ahead and I'm going to pull that out to the front. And so this can be the negative integral of 1 divided by u, now du divided by 2. Back to us for a second. Okay, and then the integral of 1 divided by u is still, it's going to be the natural log. Okay. So we're going to end up with the natural log of y is going to equal now negative 1 divided by 2 times the natural log of u. Let's see why. Okay. But remember that our original substitution was that u is going to equal 1 plus x squared. So that means that the natural log of y is going to equal to negative 1 divided by 2 times the natural log plus sigma. All right, I'm going to run out of room on this page, so I'm going to grab another one. Okay, now, in my class, unless on a test it specifically said find the explicit solution, if you had left the answer written like this, I'm going to count as correct. Okay, that's my class. Don't apply to everybody. But for in this case, this answer is not actually the best looking one. So I would want to clean this up a little bit because there's actually a nicer looking answer. And also I don't really want to solve for C at this point. Because remember, it still has an initial condition where we got to solve for C1 in that case. Would that be too bad? Oh crap, we'd have to look at the natural log. It's not too bad. Let's make it, let's clean it up tomorrow. Okay, so from there, you'd say, okay, natural log of y will equal natural log of, okay, I'll write it like this. So 1 plus x squared to the negative 1 divided by 2 power, close that, and say plus c1. Okay? And then if we raised both sides above e, we would end up with, well, y is going to equal to e to the, well, I'll rewrite it. 1 plus x squared to the negative 1 half plus c1. But remember, en does the natural log. So y would equal 1 divided by the square root of 1 plus x squared multiplied by e to the c1 would just turn into an arbitrary c. And then we could say y of 0 equals 2, right? So that means that 2 would equal 1 divided by the square root of 1 plus, now 0 squared, and 1 divided by 1 plus 0 squared is just 1. But multiplied by c, and that's going to give us that c equals 2 as well. Okay. So that means that y equal 1 divided by the square root of 1 plus x squared multiplied by 2. And that would be the answer to our problem.